All right, welcome once again to Pre-Calculus. We're learning today 6.4, which combines with 6.5 to look at the idea of a polar coordinate system. What we deal with in most of our graphing is on a rectangular grid where we have all of our x's going this direction and we have all of our y's going this direction. Okay, so we have our x grid and our y grid, and it creates a rectangular coordinate system. But what we want to do now is a polar coordinate system, and you can actually kind of think about looking at the top of a globe, and you would see if you had lines of latitude and lines of longitude on your globe, if you looked at the North Pole, you would see a basic polar coordinate system. Angles away from the zero, the prime meridian, and then angles going out or distances going outward in the lines of latitude. All right, so let's kind of look at some of the things that we are going to be covering here. So polar stuffs. We're going to start off with just the polar coordinate system in general, and I'll show you what a graph of a polar coordinate system would look like in just a moment. But what this is it's a plane with point O. So there's O. We call that the pole. So like I discussed talking about looking at the North Pole on your globe. Everybody has globes at home, right? The polar axis is only this. We can equate it to our positive x-axis. This right here is the entire graph or the entire setup. There's no rectangular grid or anything like that. But what we look at is r comma theta. Any point out here in space is an r comma theta. And you might kind of think about this pretty easily. R usually represents radius or distance, and r is going to be this distance from the pole, and theta is going to be the angle just like normal, going from this polar axis up to the line that contains r, the distance. So r is the distance from the origin, and you should be able to find distance by now, by the way. Square root of x squared plus y squared. We'll get to that in a moment. And theta is the directed angle from the polar axis. Directed just means if it's positive, it's going in the normal counterclockwise direction. So if I was to graph the polar coordinate 2 comma pi thirds, I would start with, here's O, here's the axis. I would go to an angle of pi thirds, which I know is 60 degrees, but I kind of like to do things in radians sometimes. Pi thirds. And I would go out here and I would say this is the point that's 2 units from the origin. And here you're just going to have to label, because I do have polar grids, but because we're not going to use it a whole lot, I don't really want to waste them right now. We're just going to go out and say, hey, that's 2 units at an angle of pi thirds, and that is the point. You can get rid of this, really, and you just kind of label that in there lightly as going, okay, this is 2, this is pi thirds, and that's your point right here. This is the point 2 comma pi thirds. We could do the same thing for this one. We could say, okay, let's go back to red here and say, here is my O, my origin, my pole. I'm going to go in a negative 45 degree angle, which is right about there. I'm going to create a point that is 3 units from the origin, or a distance of 3 from the origin. And I'm going to label it as such, this being the point 3 comma negative 45 degrees. Okay, pretty simple, pretty straightforward. But we are going to compare this to the rectangular system in a few moments. Okay, don't worry about Desmos. I'm going to go to that in just a second. But this next question is actually a very challenging question because people always mess this one up. So here I have my pole, I have the positive x-axis, and what people are really tempted to do is they're to do this. And this is actually what you want to do. You want to go to 3 pi fourths. Well, 3 pi fourths is right there. I'm going to undo that, do that in green. Okay, so 3 pi fourths is a 45-degree angle in quadrant 2. And people are just tempted to do this and to go out 2 units. But then you've defeated the purpose. This particular point is the point 2, comma 3 pi fourths. But that's not what I wanted. I wanted negative 2 3 pi fourths. And this is where people get a little messed up. Negative radius means instead of going in the normal direction, it says go in the opposite direction. So this point right here, this little dot here, is actually negative 2, comma 3 pi fourths. So you start by going in the direction that you want to go, find the angle, but then instead of going out, you want to go in the opposite direction. So it's just straight line back. So let's take a look at what Desmos is going to do here. And if you go to Desmos, I got to erase my stuff here. If you go to Desmos, usually it's just desmos.com. It's going to start off as a rectangular grid, but you go to this little monkey wrench up here. Oops. And you can change things to this circular grid. This is a polar coordinate system. So notice, I know it leaves the XY coordinates or XY grid in here, or graph, axes, whatever you want to call it, but by definition, it's only usually one line. But they kind of reference this as a 90-degree angle, pi, and 3 pi halves. So you can actually draw coordinates in here. If I went 3 units at a pi third angle. Okay, so you notice that this is 10 units from 0. So I'm going to zoom in, just scrolling up or up on your mouse pad or whatever. I should be 3 units at a pi thirds angle. Am I in the right mode? I'm in radians. This is not coming up correctly. Okay, I will change these to degrees. 60. I don't know why Desmos is not working for me today. I've done this plenty of times before, and it's worked fine. So I'll figure out Desmos. You should be able to figure this out, though, on Desmos here. If you change it back to radians and I do such like this. If I go to negative 2, comma, pi thirds. So I think Desmos is thinking things backwards. I'll figure Desmos out, but Desmos will show you a polar grid. I really wanted to show you what a polar grid looked like. The graphing of points isn't too challenging, but a polar grid is going to look like this. And if you think about it, this does actually kind of look like what your graph would look like looking down at the pole on a globe. All right, let's go back to the PowerPoint since Desmos is not working for me today. Every once in a while, you're going to be asked to find all coordinates, and this has to do with coterminal angles. So you might remember that from trigonometry from last semester. If you were to be looking at a coterminal angle, let's think about pi thirds. Pi thirds is right here. A coterminal angle is just adding 2 pi a whole bunch of times. So we just keep rotating, and this would get me all of the same value. So 3 units out and pi thirds comma 2n pi, or pi thirds plus 2n pi. But that's not all of them. There are others. What about if I had a negative 3 pi thirds? Well, negative 3 is going to actually be out here, but I could add 180. I could add 180, and this is going to look like this. I know it looks a little bit different, but what we want here is, in order to do anything here, for every r comma theta, here's what you need to do. In order to find all different coordinates, you would do r comma theta plus 2n, and you would do the opposite of r and theta plus 2n plus 1. And by the way, 2n plus 1, if you guys are unfamiliar with this, 2n is all of our even numbers, and 2n plus 1 means odd. So here, I'm going to, if I was down here at negative 3, I would have to add 1 pi, and then I would have to add 3 pi to come back, then I would have to add 5 pi to come back, 7, 9. So I'd have to add odd values for pi. It's a very simple little thing to just kind of follow. All right, let's look at conversion, because this is the kind of the bigger thing for polar equations. We can convert some, not every single one, but we can convert most of our polar equations into polar, or into rectangular, and some of our rectangular into polar. We can do it pretty simple with some very basic conversion factors. If you're given a polar coordinate, we know rectangular coordinates are x comma y. And you can think a lot about what we did with trigonometry, where we found the r value using the distance formula or Pythagorean theorem, and we found the theta value by doing tangent of y over x. Or actually, sorry, tangent of theta equals y over x. So here's our first little conversion. X represents r cosine theta, and you can think about that very, very simply. If I had a coordinate out here that is x comma y, this is r, and I need to find theta. Well, this is x and y. That tells me that the cosine of theta is equal to x over r. So if I want a conversion for x, I can just multiply by r, and I get x is r cosine theta. And we know that x squared plus y squared has to equal r squared. That's basic Pythagorean theorem. Likewise, we can say that y is r sine theta because sine of theta is equal to y over r. What this means is now we can convert, and tangent theta is y over x, just like I said there. There's theta. We can now convert using these 4 basic ideas. So we want to convert 3 comma 5 pi over 6 into x comma y. Well, what's kind of nice is we want to x comma y. Well, I know x is r cosine theta, so it's actually going to be r cosine theta comma r sine theta. Well, I have my r is 3, and the cosine of 5 pi 6, and 3 sine of 5 pi 6. And you plug that in your calculator, and you should get negative 2.6 comma 1.5, which kind of makes sense because 3 comma 5 pi 6 is in quadrant 2, and we get negative and positive in quadrant 2. So these two coordinates are exactly the same thing. One's in polar mode, one's in rectangular mode. And we do have a polar mode in your graphing calculator as well, which we will be using. So we can also convert the point negative 1, 1 into polar mode by just going the opposite direction. I know that r squared is equal to x squared plus y squared. So I actually want r is the square root of negative 1 squared plus 1 squared, which is radical 2. And I need to know theta. Well, I know theta is tan inverse of 1 over negative 1. Here you just have to pay attention. Tan inverse of negative 1 is going to give you on your calculator negative 45 degrees. However, this coordinate is in quadrant 2, where this angle is in quadrant 4. So I need to add 180. So adding 180, I get 135 degrees, or 3 pi fourths. And I get this version here. But you could have gotten this. If you used this negative 45 degrees, all you would have to do is make your R value negative. So being down here, if I said negative 45 degrees, if I said a negative radius, I will get up here into quadrant 2. So there's 2 ways to write that answer. Well, what about equations? These are actually kind of fun graphs to be dealing with, and you could just go right on your calculator right now and graph 4 cosine theta. Let's see what would happen if I just did that. See, is Desmo's still up there for me? If I said, oops. If I said 4 cosine, let's see if it works for me. Of course it's not. I haven't fully played with Desmos just yet. It works a lot better on your calculator. There's less to deal with. So if you graphed 4 cosine of theta, if you go in and change your mode to polar mode, you notice you get an R1, R2, R3. Then you go 4 cosine of theta, and you graph it. You actually get, oops, gotta go back to my pen. You'll notice this, which is actually a circle. That's kind of cool. So let's figure out how to change this. Now this takes a little bit of process, but what you're going to do is you're going to multiply both sides by r, and you'll see why in a second. So when you multiply both sides by r, you get r squared equals 4r cosine theta. Now, that's really handy because I know that r squared equals x squared plus y squared. And I also know that x is equal to r cosine theta. Well, I have an r squared that I can replace, and I have an r cosine theta that I can replace. So I'm going to do that. So I have x squared plus y squared equals 4, which is not exactly finished. Yes, that is a rectangular mode or rectangular equation, but it doesn't really tell me what the equation is. It kind of makes me think it's a circle. So you have to go through this process just like we used to do in the beginning of the school year and some Algebra 2. So minus 4x from both sides. Complete the square. So half of 4, so negative 4 over 2. Doesn't matter about the negative 4. 4 over 2 squared is 4. So I add 4 to both sides of the equal sign. Because now I can factor this. I get x minus 2 squared plus y squared equals 4, which tells me it's a circle whose center is, oops, sorry, this was supposed to be a 4 there, with center of 2, 0, and a radius of 2. It's pretty cool. At least I think it is. What about r equals 4 secant theta? This one always kind of trips people up. That's why I've added this to the video. I don't always add this to the PowerPoint here. So r equals 4 cosine theta actually is r equals 4 over cosine theta. And I can multiply both sides by cosine here, so I get r cosine theta equals 4. Well, again, r cosine theta is x, so I get x equals 4, and that's a rectangular equation for a vertical line at x equals 4. Super simple. These ones are much simpler than the circle versions. But this is actually, I didn't really mention this, but this is actually kind of cool. This very, very basic equation is a circle. That is such a simple equation for a circle when we write things in polar mode. It's kind of cool. But you know me. All right, what about converting this to polar mode? So we already went from polar to a circle. Let's go from a circle to polar, and let's see what we would do. Well, I'm going to mention what we do. We're going to FOIL. Everywhere we see an x squared plus y squared, we're going to replace it with r squared. And we're going to replace x and y with our conversion of x equals r cosine theta and y is r sine theta. So let's do this. Let's FOIL. We get x squared. I'm going to have to go a different spot here. I'm going to go right here. I'm going to get x squared minus 6x plus 9 plus y squared minus 4y plus 4 equals 13. If I get all of my constants on one side, minus 9 minus 4, oh, that's nice. I get x squared minus 6x plus y squared minus 4y equals 0. That's cool. Then, kind of working backwards here, I got all my quadratics on one side and my linear pieces on another. So I'm going to say x squared plus y squared equals 6x plus 4y. Well, x squared plus y squared is r squared. X is r cosine theta. And y is r sine theta. And then I can divide both sides by r. Don't take the square root. This tells me that r is 6 cosine theta plus 4 sine theta. And again, that is super cool because this is a circle with center 3, 2, with a radius of root 13, written in a much, much simpler form in polar mode. All right, last problem for this video. Radar detects two planes at the same altitude. Their polar coordinates are 8 miles, 110 degrees, and 5 miles, 15 degrees. This is kind of, if you've ever watched movies and they have this big circle and they have this little dot in the middle and then they have the sweeping line, the radar. Radar is based off of a polar graph because that's what they have. They have little concentric circles that are distance from your boat or plane or submarine or whatever. And it's scanning to see at what angle and all that sort of fun stuff. And this is a real life situation, right? They do polar equations all the time. So let's think about this. If I was to get, oops, let's delete that. I don't need that. If I was to think about you sitting right here at your radar station, here is 0 degrees. I know the first plane sits at 8 miles, 110 degrees. So 110 degrees is right here, 8 miles. The other one is 5 miles, 15 degrees. Now, the question is, how are you going to do this? You want to find the distance between these two planes. Well, you'll notice that that just created a triangle. And if this little angle in here is 15 and the big angle is 110, the angle right here is 110 minus 15, which is 95 degrees. And a 95 degrees, well, look at that. That's side angle side. And side angle side says use law of cosines. So if I called this C, C squared is equal to 8 squared plus 5 squared minus 2 times 8 times 0.05 times the cosine of 95 degrees. And therefore, C is whatever that ends up being. Let's do that really quick. Square root of 64 plus 25 minus 1, or what is that? 40 times 2 is 80. And then I write 40. 80 cosine 95. Make sure I'm in degree mode. I get 9.7. Or 9.8, really. And we're dealing with miles, so they are 9.8 miles apart. And that does make sense that that has to be bigger than 8 because 95 has to be the biggest angle in my triangle. All right, nice and simple. I think I gave you one problem like this. I'm going to leave you with this. I hope this enlightened you. Not necessarily a quote, but I hope this lesson enlightened you to show you that there are more than just the rectangular grids. All right, I will see you guys in the morning.